Hello, my name is Ed Kammerer. I'm the Director of Global Product Management here at OPW Retail Fueling. Thanks for joining us for another installment of our Gas Station 101 videos. What we're doing is we're putting together a series of videos to help people that may be new to the petroleum industry, to help get a better understanding of the equipment, the terminology, and some of the regulations that are found at retail gas stations. If you haven't already, I would suggest checking out Retail Gas Station 101, where I go over the operations of a gas station and describe the equipment, the terminology, and the regulations that drive some of the equipment that's found at a retail gas station. It may help you understand some of the things that we're going to talk about today in this video. We've also put together a series of other 101 videos. We've made a video on automatic tank gauging that describes how a tank gauge operates, the types of equipment that's found in those systems. We've also done a dispensing hardware 101, which is all the nozzles, breakaways, swivels that hang on a dispenser, the type of equipment that you use when you actually fill your vehicle. So these videos will help give people a better understanding of the whole picture of a retail gas station and how all these components work together. Today in this video, Piping and Containment 101, I'm going to specifically be talking about the underground piping system. Now, piping and containment usually don't get the same glory that nozzles, manholes, and spill buckets get because they're not something that's handled or seen every day in the day-to-day operations of a gas station. However, it's one of the most important components of the system when you're moving gas from the underground storage tank to the tank in your vehicle. The system is also designed to make sure that fuel is kept out of the ground and is supplied safely at a retail gas station. So in this video, we'll be talking about the four components that make up an underground piping system. So first, there's the actual pipe itself. Then we'll talk about the fittings or the connections that go on the end of the pipe, and then the associated fittings that those connect to. We'll talk about containment sumps, both dispenser and tank. And then we'll also talk about entry fittings, where the pipe enters those containment sumps securely and safely. Okay, so let's first talk about piping. Now, in the old days, steel pipe used to be used to get product from the tank to the dispenser. But as you can imagine, burying steel in the ground wasn't a very good idea. Things like rust and corrosion would cause the pipe to leak and create an environmental nightmare. So the industry has kind of evolved over the years away from steel pipe, and we've gone into some other materials that you'll typically find at a retail gas station now. As we described in the earlier video, all piping that's in the ground is required to be double wall or secondarily contained. So what that means is there's a primary pipe, and there's usually some type of secondary pipe on top or over the primary pipe. And the purpose of that is if the primary pipe should fail, there's basically a backup plan or another layer of pipe to contain product where it can be detected, and that pipe can be would have to be replaced. But in the event of a failure of the primary pipe, the secondary pipe keeps gas from getting in the ground, which is really the ultimate goal of all piping systems, is to keep gas out of the ground. So let's talk about the three types of piping that are used at retail gas stations currently. The first style is a fiberglass pipe, or an FRP, fiber reinforced plastic. Now this pipe comes in two styles. It's also referred to as rigid pipe. So the piece of pipe that I'm holding here now is called LCX, where the primary pipe and the secondary pipe are in close proximity with an interstitial space. This pipe comes in sticks, usually 20 to 30 feet, and then at each connection there is a fitting, a 90, a T, or a 45, and the pipe is laid out in the system and piped into from the tank to the dispenser. The problem with fiberglass pipe is because it's only 20 and 30 feet lengths, there are joints buried in the ground at every length of pipe where it has to be extended, or a T is placed, or a 45 is placed. The second style of pipe, which I don't have here now with fiberglass pipe, you have a 2-inch single-wall fiberglass pipe, and then they run it inside a 3-inch piece of fiberglass pipe with fittings that connect it. The interstitial space is much larger. It tends to be a little bit more labor-intensive, but again, you're burying joints in the ground. The next style of pipe is what's called a semi-rigid or a fusion welded pipe. It kind of still has some of the similarities of a rigid pipe, but it can come in longer lengths. So you can actually make a continuous run from a tank sump to a dispenser sump without having to bury that fitting in the ground. Now, this pipe also is double wall. there's a single wall with a secondary pipe. But the way that these fittings are put together, fiberglass pipe fittings are glued together, where these are actually welded together or fused together. There's steel coils inside here that are heated up. The pipe melts together and connects the fittings by welding them together, and then this pipe is also welded to the side of a polyethylene dispenser sump, so there's no glue packs, but you have these joints and these fittings that are actually welded in the ground to put these pieces of pipes together. Okay, so the third style of pipe that I want to talk about, and probably the type of pipe that we'll spend most of the time on in this video, is flexible pipe. So the big advantage that flex pipe has over these other two pipes is the fact that it comes on a continuous roll, or it comes on a big roll, so you can make a continuous run from a tank sump to a dispenser sump without having any joints or fittings in the ground. The other advantage is the connections or the fittings that you do have are all contained inside of a containment sump. So that way, if you ever need to access this fitting to repair or replace it, you can do it above grade through the sump, and you don't have to dig up anything in the ground. Or if you need to replace the entire piece of pipe, when this pipe is installed, it's actually installed in an access or a chase pipe. So what this does, it gives you the ability to pull this whole piece of pipe out without digging anything up in the ground. You pull it out through one of the sumps and you can replace it with a new piece of pipe. So a big advantage that flex pipe has over semi-rigid and rigid pipe. The other big advantage that flex pipe has comes in the time of installation. So again, flex pipe comes on a big roll. You roll it out, cut it to length, put the fitting on the end, put the pipe through the access pipe, put it into your sump and make the connection, and you're done. This can be done in any type of weather. Extreme cold, extreme heat, driving rain, driving snow. There's really very little limitations to the conditions that you have in the field when you go to install this pipe. Not so with some of the other pipes. Because you are putting together fittings, whether you're welding them, there's a certain amount of time it takes for each weld to cure, or whether you're putting the pipe together with glue packs. Again, each fitting or each joint has to be glued or welded together, and that can take a lot more time in the installation versus a flexible pipe install. Again, weather plays a big part with the installation of these pipes as well. A lot of moisture or rain in the air makes things hard to glue, or the plastic won't weld properly with a lot of moisture in the air. So one of the big advantages and why we see most marketers today putting in a flexible pipe for the underground system. Okay, so let's talk a little bit more specifically about flexible pipe. Now, years ago, there were a bunch of companies that made flexible pipe, but the problem that a lot of these companies ran into is they didn't always use materials that were compatible with fuel. What I mean by that is they made a pipe with a liner that had a good material that was compatible with fuel, but the rest of the pipe may have been made with materials that weren't necessarily compatible with fuel. And what would happen is, as these pipes were in these sumps, sites weren't always maintained as properly as they should have been. Fuel would end up inside sumps, and the outside of the pipe would be exposed to fuel over a long period of time, causing the pipe to swell and crack. And so over the years, a lot of flex pipe has been removed from inside the ground. Now, the companies that have survived the test of time with putting a flex pipe in the ground are the companies that have used materials that are compatible with fuel throughout the pipe. This pipe, for example, the liner, the material used for the liner is called Kammerer, or it's a PVDF, a polyvinylidene fluoride, which is a very dense, one of the most dense plastics known to man. So it's a great barrier against anything that may come in contact with it. PVDF, or Kammerer, has been used in the petrochemical industry for over 50 years. Has a great track record. They use it in the oil fields when they're pumping crude offshore, or in the chemical industry when they need to line a plastic pipe with the material that'll be almost impervious to about anything that you can run through it. This pipe, for example, then the liner is Kammerer, the outside of the primary pipe is Kammerer, and then this jacket or secondary containment is also made of Kammerer. So if you think about it, there's 4 potential surfaces that could see fuel: the inside of the primary, the outside of the primary, the underside of the secondary, or the outside of the secondary, all four of those surfaces are with a material that's truly compatible and will not permeate with gasoline or even alcohols that's in the gasoline. So these are the types of pipe that have survived the test of time, and why we continue to put these in the ground with a very, very extremely high rate of success. Okay, so we're back out here at our plant in Smithfield, North Carolina, and now we're on the extrusion line. This is where we actually make the flexible pipe that we've been talking about. And I'm here with Brian Thompson. He's our lead supervisor on the extrusion line. So Brian, tell me a little bit how this extruder works and what we're looking at here.
All right, well today we're manufacturing our Kiwa pipe, or GFP pipe. So we have three main extruders down here at the primary, and we are putting in polyethylene on that machine over there. Here we have our Kammerer material, and in this one, our tile layer material. The materials are extruded through the extruder, then they go into the die, where the die is pushed the material into the vacuum tank.
Okay, cool. So once it comes through the vacuum tank, we'll walk down here and see what the pipe looks like as it's coming out of the tank.
Inside the vacuum tank, that is where your pipe is being sized and it's solidified. From here, it goes into the next machine, which is a puller, and the puller is actually doing exactly what it says. It's pulling it down to the next station.
Great, okay, let's go on to the next station.
On this station, this is just another 2-inch extruder. We're putting on another layer of polyethylene. From here, we go down to the next station, where we're actually putting on 2 more layers. On this smaller extruder over here, we are adding our nylon, and on this one, our Orvac. From here, because we're adding more layers, the pipe is now warming back up. So to keep the pipe concentric, we're adding, or we go through the cooling chamber, which is just adding on cool water.
So these tanks are just filled with cold water?
Cool water. Here we have another puller that's just keeping the tension on the pipe and keeping it going down to the next station. Okay, so now we're at the next station, and we have 3 more extruders. This is the beginning of the secondary pipe. So we have polyethylene being put on in this extruder, our tile layer material, and at the other extruder on the other side, our our Kammerer. All right, so now that we're coming through the jacket head, we're gonna go into the back of the vacuum tank, where the sizer is sizing the materials as they're coming into this tank. Is also spray on this end. Each reel is air tested prior to going to shipping. We also take a sample off of each reel and check for bond, layer thickness, and concentricity.
So here you have it, folks. This is where all the extrusion magic happens. This is where all sizes of the pipe, the 3/4, the 1 inch, the 1.5 inch, the 2 inch, and the 3 inch are all extruded on this line. Okay, so most flex pipe is manufactured in many different sizes. It's made in 3 inch. The 3 inch typically used at a truck stop application where you got a high flow, you're moving a large volume of diesel fuel from a tank sump to a dispenser sump to fill large trucks. It's also used in bulk plants, again, where you're moving high volumes of fuel. 2 inch. Found it in most retail gas stations, especially the larger ones where you're feeding multiple dispensers from one submersible pump. 1.5 inch is also used at a retail gas station, usually the smaller ones, not the big mega stores. And then this pipe is also made in 3/4 and 1 inch, and this pipe would typically be used in a fuel oil application at a hospital or a building where they have a backup generator or a boiler, and they're feeding fuel oil from an underground tank over to the building with a generator or boiler. They'll run it in 3/4 or 1 inch pipe. So these are some of the various sizes that you'll see in flexible pipe. Again, these pipes can all be or is usually run inside what we call an access pipe. It's a 4 inch conduit. So again, gives us the ability to retract this pipe once it's in the ground if the pipe ever has to be pulled out. Okay, so let's continue our conversation with flexible piping. Now, the way this works is this pipe comes off an extruder, and then it's wound on a big reel, and then shipped to the site, usually 250 feet, 500 feet, or in 1,000-foot rolls. Then what the contractor will do is he'll take his measurements from his tank sump back to his first dispenser sump, and then from dispenser sump to dispenser sump, and determine what lengths of piping that he needs. Then what he'll do is he'll cut that pipe to length. Now, we need a way of connecting the pipe once it's been cut, or connecting it back to the submersible pump, or to a 90 or a T fitting at the base of a riser pipe to get the fuel up into the dispenser. So the way this works is there's basically two styles of couplings or fittings that go on the end of the pipe. The first style is what's called a swedge fitting, and this is actually mechanically fastened on to the end of the pipe. There's a swivel nut at the end with a flat gasket, and that would seal against the 90 or the T. The other style is called a bolt-on or a clamshell fitting, where it's simply more or less a hose barb that goes inside the pipe, and then two clamshells that come down and are bolted together and holds the hose barb inside the pipe. And then this fitting is actually an NPT thread, so it would just simply thread into a standard off-the-shelf 90T or back to NPT ball valve at the submersible pump. So the way these work is the bolt-on or the clamshell. Like I said, the pipe would be cut to length. This is the inside of the bolt-on coupling or the hose barb. So this would be threaded either already into the ball valve at a submersible pump, or it may be threaded into the bottom of a 90 or a T at the bottom of a riser pipe inside of a dispenser sump. So this is fixed. The pipe would be slid over the barb. Then you take the two pieces of clamshell, and then those would be bolted together. Use an impact wrench or a torque wrench or just a standard wrench to tighten those down. Holds the fitting on the end of the pipe, keeps it from leaking, and then we hook it up. Now the other means is the swedge fitting. This is basically how hydraulic hoses are made. It's an internally expanded coupling on the end of the pipe. They both have their advantages and disadvantages. The advantage to the bolt-on is it doesn't require a machine. But the disadvantage is you're relying on the contractor to tighten these bolts down tight enough or at a specific torque setting, whereas this is actually done by a machine. So you know mechanically it's fastened onto the end of the pipe. You're not relying on the contractor to perform that operation. Now the downside to the swedge-on fitting is it does require a machine on site, a specialized machine. So real quick, I'm just going to demonstrate how this works. This is a 2-inch pipe. This is our 2-inch coupling, our swedge coupling. So we'll take the fitting, apply a little bit of moly grease to the inside of the fitting. It's going to go onto our swedge machine. And then this swedge or the swedge block, what's going to happen is it's going to be drawn through the inside of the coupling, expanding the inside ferrule against the outside ferrule and basically crushing the pipe in there and sealing it at the end of the pipe. So that'll thread down onto there. The pipe slides down onto the fitting till it bottoms out, and there's basically just a hydraulic motor in there that's pulling a shaft down and drawing that swedge block down through the pipe. So that's going to run through there. Again, the advantage is this is actually a mechanically fastened fitting on the end of this pipe versus a manual fitting that's done in the field. So once that runs through, our fitting's put on the end of our pipe. The gasket inside here is what seals. Now the other difference between these two style fittings is the actual thread that's on the fittings themselves. So the swedge-on fitting, the thread that's actually on that male swivel nut is not an NPT or a tapered thread. It's a specialized, what we call a flat thread or an MPSH thread. So it does require a special fitting to thread onto. So these would be fittings provided by the manufacturer. This would go on the end of a riser pipe inside of a dispenser sump, matching the flat thread here. And when we thread these on, there's no lubrication, no grease, no type of pipe dope. You're just going to tighten that up, and that flat washer, or that flat gasket's going to actually make the seal on that fitting there. So the same inside the tank sump. Coming out of the ball valve is threaded NPT. So you would take this adapter, thread the adapter, one side NPT into the ball valve, and then the other side would be the flat thread that would match up to the pipe coupling itself. So again, those, and the way we do these in the field, those would be hand tightened and about a half a turn on the wrench. You don't want to over tighten the flat washer or the gasket. So that's how that connection is made. Now with the bolt-on, because it's an NPT thread, NPT is a common thread that you find any off-the-shelf plumbing fittings, galvanized or stainless. It doesn't require a special fitting from the manufacturer. This would just simply thread into the ball valve or thread into an off-the-shelf 90 or T. Now the disadvantage is you would have to put pipe dope on there and crank on it pretty hard to get a tight seal. So these are the two types of fittings that are put on the end of flexible pipe. Now if you notice, there's a port right here. Actually, in the old days, and what some of the other manufacturers do with their flex pipe is, because we have to access the interstitial space. Remember, this is a double wall pipe, so there is a primary pipe and a jacket over top of this. There's a small interstitial space between those two pipes that needs to be tested at the time of installation, or may be required to be tested down the road. But we need to have access to that space or be able to put air on there to test it. So originally what would happen with the flex pipe is you would actually have to trim this jacket back and expose the primary pipe, and then your coupling would go on the end, and then you'd have a gap between the edge of the secondary pipe and the primary pipe. Like this piece of pipe here, this is actually the primary pipe. The jacket's trimmed back into here, and then a rubber test boot would be placed on there to force air through that interstitial space so you could do the test. The problem with that, it requires, again, a special tool in the field to trim that jacket back to make sure it's trimmed back at the proper length. It's another step that the contractors have to perform. So it was it took a lot of time to trim every piece of pipe back to put that fitting on. So several years back, the new style fitting was introduced. It's basically a double wall fitting where the test port is actually built into the fitting itself. We no longer have to trim the jacket back. We'll just cut the pipe to length. The fitting will go on the end, just like you saw with the barbed and with the swedge-on fitting. And now that test port, again, is built into the fitting. So what happens is that pipe is only pushed up to a certain point where it stops. So through that test port, we allow access to the interstitial space and can force air through there and run a test on that interstitial space. So a big time saver for the contractor, and it's also a much better means of testing the secondary with a permanent test fixture built into the fitting versus having to rely on a rubber test boot that's clamped on the outside of the secondary and then on the outside of the primary and forcing air through that way. So a big advancement in these fittings that go on the end of the pipe. Now the way that we test that or get air in there, it's basically just 1/8 of an inch threaded port. We thread a brass fitting, similar to the water hose on the back of your refrigerator for your ice maker. Nylon hose goes on the end of there, and then this would thread on. And then if we go between, if there's a T junction here and we need to jump across it, there'd be a similar fitting here, and this would jump. Or at the termination end, we would put a test fixture on here with a ball valve to add air with a test gauge to put 5 pounds of pressure on that secondary pipe. So that's how we get air and test the interstitial space on the double wall pipe. Okay, so let's talk about the next component of our underground piping system, and that is the tank sump. So if you remember from Gas Station Retail 101, the tank sump sits on the underground storage tank, and this is actually what houses the submersible pump. So our submersible pump is inside of there, what pushes the fuel from the tank over to the dispenser to get in the vehicle. Now, those submersible pumps is a mechanical pump, and so they need to be maintained or accessed occasionally for maintenance or repair. So you need some type of chamber to provide that work area to get down in there to access the submersible pump. And that's exactly what the tank sump does. It's a chamber to house that pump, and in addition, it contains the piping connections. If there's any leaks in the submersible pump, any of the connections, it's actually contained in this chamber and doesn't end up in the ground. So two types of tank sumps, or two types of materials that we use when we manufacture tank sumps, polyethylene and fiberglass, and both have their advantages and disadvantages over each other. So let's talk about the polyethylene tank sump. So these come in usually different heights from the factory based on the depth or how deep your tank is buried. So there's a shallow bury, a medium bury, and a deep bury tank sump. The ribs here act not only as a structural rib to help maintain the rigidity of the polyethylene, but it also gives us the ability to height adjust this sump in the field. So if we needed to, make the sump a little bit shallower, basically we cut right between these ribs, and then that rib now becomes a sealing surface for the gasket. So these are sealed with a gasket and a lid, and then some type of means of compressing that gasket. The polyethylene tank sumps tend to be a little bit less expensive than the fiberglass tank sumps. They're traditionally mounted with a mounting flange on top of the tank that we'll talk about later. The sides on the bottom we do as flats to make better entries for our entry fittings and for our tanks. And we'll talk about that later in the video. But there's a reason that these surfaces are flat around the bottom of the tank sump. They generally come in two different diameters, usually like a 33-inch diameter or a 36-inch diameter, based on either whether you have one submersible pump inside the tank sump, or sometimes you'll have two submersible pumps inside that tank sump, so you need a larger diameter tank sump. So the other material that's used in the manufacturing of tank sumps is fiberglass. And one of the advantages that fiberglass has over polyethylene is it's a little bit more rigid, a little bit more stronger. So we tend to put fiberglass tank sumps in higher water table areas. We want to make sure we definitely keep water out and keep the sump from deforming. So the other advantage that a fiberglass sump has is you can actually bond it right to the top of the tank. And we'll talk about that later in the video when we describe the ways of attaching tank sumps to the tank itself. The other advantage that the fiberglass tank sump has is it comes in two pieces. So there's a joint in the middle, and what this allows you to do is once this bottom base is set on the tank, either with a mounting flange or a collar ring, you have a lot of space to work in as you set your submersible pump and make all your connections. Again, fiberglass, the bottom similar to the poly, where we make flat sides, make it easier for the entry fittings to come in and the pipe to come in. But what this does, it gives you a lot of room to pipe up your connections to the submersible pipe, run your conduits. Once that's all done, there's a channel here. We'll take a 2-part resin, mix it, pour the resin in that channel, and then when we're ready, we'll place the top section back on top, and we've glued the bottom and the top, actually bonded the two pieces together. But it gave us a lot more room during installation. Fiberglass tank sump can also be height adjusted. With this model here, basically you would cut the bottom off here as high up as you needed to help lower the burial depth of the sump. So, two types of tank sumps made in both fiberglass or also in polyethylene. And then next we'll show you actually how these are mounted to the tank or to the underground storage tank itself. Okay, so let's talk about how we actually attach our tank sump to our underground storage tank. And there's basically two methods to do that. And we're fortunate here at OPW we actually have an actual underground storage tank that we've cut away to kind of use as a training tool to show people different things that happen on top of the underground tank. So the two methods that there are to attach tank sumps to underground storage tanks is what we call a riser or collar mount or a flange mount. So one of the big advantages that fiberglass has is it's able to be bonded or glued together with another fiberglass part. So what happens is the fiberglass underground storage tank comes on site with this fiberglass riser that's bonded right at the tank factory and shows up on site with this fiberglass riser. Now the tank sump is the bottom of the sump is the exact diameter of that riser collar, and what you can do is this sump will either come already without a bottom, or you can simply remove the bottom, and it matches right up with the riser collar. Those two pieces will fit together, and there'll be a channel where you take a two-part resin and fill that channel with resin, and you've actually glued the tank sump or bonded the sump right to the tank itself. So it's a strong method, great method that keeps water out, keeps gasoline in. So it's a very popular means of attaching the fiberglass tank sump to the fiberglass tank. Now the other method is with a mounting flange. These mounting flange will thread right into the 4-inch bung on the tank, and you would typically find this on a steel tank where you don't have the ability to have a fiberglass riser, or on a fiberglass tank that's maybe existing in the ground that doesn't have a riser, and you need a way to mount the sump to the tank itself. So the way this works, it threads into the 4-inch bung on the tank, and then it's basically a flange. So this can be used either with a fiberglass tank sump that has a bottom in it, or a polyethylene tank sump as well. You'll drill a hole in the bottom of the sump and match it to the flange on this mounting flange, and it bolts down and creates a tight seal with the bottom of the sump. Now, advantage, this is usually a little bit lower cost, but the advantage that this has is not only is it bonded right to the tank itself, but it also gives you complete access to the manway that's on top of the tank as well. So you can get down, and if you ever need to enter the tank, you can do it right through here, through the manway that's built into the tank. Okay, so let's talk about the next component of our underground piping and containment system, which would be the dispenser sump. So the purpose of a dispenser sump, again, is to give us access to any type of connections that occur. In this case, it'd be the connections that happen underneath the dispenser. So this would be buried underground in the concrete, and our actual dispenser would sit up on top of here. So these are each dispenser sump is ordered to fit the specific style or the specific model of that dispenser, because they're all different size footprints. So we manufacture a sump that matches up with each of the models of the dispensers that are out there. So again, this would be buried in the ground. Our dispenser would sit up top. Our piping connections that come from the tank sump or from another dispenser sump actually come through the sidewall of the sump, and then again, all those fittings are connected within this chamber. That way, if something were to leak inside the dispenser, or any of the piping connections should fail or leak, they're actually contained in this sump and don't end up in the ground. Okay, there's a couple different materials that are used to manufacture dispenser sumps. The first one is polyethylene. It's made on a roto mold, which we'll take you out to the plant and show you a little bit later. But the polyethylene sump is made from a mold, and then we attach the metal frame. This frame actually holds the bolts, which will the dispenser itself bolts down to and is held into place. Our piping connections come in the side of the sump. And again, the purpose of the dispenser sump is to contain any leaks that may happen underneath the dispenser in any of the piping or connections, or if we just simply need to access the piping connections that are down there in the chamber. It gives us a way to get down in there and get access to those fittings. Okay, so the other material that dispenser sumps are traditionally made out of is fiberglass. And there's a couple different manufacturing methods to make a fiberglass sump, and we'll talk about that a little bit more when we're out in the plant. But there's an RTM style, or there's a spray-up style. This is an example of an RTM, where you have a smooth side or smooth surface on both sides because you're pulling through a double-sided mold. Or fiberglass sumps are also made what's called a spray-up. There's a one-piece mold where you spray with a chopper gun. The resin and the glass is fed in, and you spray the side of a mold to make the dispenser sump. These are also come in different models. This one here is a two-piece. Again, there's a one-piece or the box or the bottom where you would set this sump, make all your connections, and once you're done, you can set the top on. Or similar to the polyethylene dispenser sumps, there's a one-piece fiberglass tank sump. Again, this can be cut down in the field to adjust for grade, and then the frame attaches, and you're ready to go. So Polyethylene or fiberglass dispenser sumps. Both have their advantages and their disadvantages. The polyethylene tends to be a little bit less expensive. The fiberglass are used in higher water tables or where you need something that's a little bit more rigid, or if you want to bond a fiberglass pipe directly to the sump, you would use a fiberglass sump. Or if you're using a semi-rigid pipe and you're welding, you would weld that fitting to a polyethylene dispenser sump. Now on the dispenser sumps, you may notice a channel here or an offset frame or the channel in this box here. And what that's for is original systems, when we brought electricity to the dispenser, conduit would be run underground. The conduit would actually penetrate the side of the dispenser wall, come in and come up through and give power and communication to the dispenser. Well, the problem with that is, you're putting another entry fitting in the sump, which could potentially be a leak point, or a lot of times conduit will actually collect water inside the conduit and will actually bring water into the tank sump itself. So several years ago, the industry kind of transitioned from running the conduit to the side of the sump and actually bringing it up through the outside. So that's what this channel here is for. The conduit would come over, it would turn up, run here, and come actually through the frame of the sump, and then enter the dispenser between the frame and the skin of the dispenser and feed power and communication to the dispenser that way. In this case, the frame is offset, so we'll bring the conduit up through here. Conduit again comes up between the frame and the skin of the dispenser, giving it communication and power. Or again, in this fiberglass sump, there's a molded channel for the conduit to come up through the side of the sump, up through the frame of the dispenser, and into the dispenser itself, providing power and communication. So these are examples of conduitless sumps, which is primarily what you see people installing these days. Okay, so the dispenser sumps that we just went over are actually the sumps that will be found in a traditional piping system. And what I mean by that is the sumps are set in position based on where the dispensers are going to be located, and then the contractors will determine the product inlets based on the footprint of the dispenser, and then they'll drill holes in the sump, put an entry fitting, and then the product piping actually runs perpendicular into the sump where it comes into a 90 or a T, and then feeds a riser pipe up to the dispenser. Well, a few years back, another style of sump was introduced to the petroleum industry, and it's what's referred to as the loop sump or the loop system, where with this sump, actually instead of having flat sides and the pipe entering perpendicular, here the pipe actually loops up and penetrates the sump at a 45-degree angle. A couple advantages here: the loop sump is a little bit shallower. So if you have a high water table, it brings it up out of the water table, less likely to have water penetrate the sump or the sump to be deformed due to those high water pressures from high water tables. The other advantage that this sump has is when it shows up on site, all the entry fittings are already installed at the factory along with the stabilizer bars and the impact valves. So the contractor just simply pulls this sump out of the box, sets it, and runs his pipe. There's also no riser pipes in this system. As the pipe comes up through the bottom of the sump at a 45, the pipe actually connects right to the base of the impact valve, so you're not cutting and threading riser pipes in the field and making that connection. So we see a lot of marketers going over to this style of sump simply because of the advantages it has being shallower up out of the water table. It's a much quicker, easier install for the contractor. A lot less problems can happen during the installation. Again, these are conduitless as well. We bring the conduits on the outside up to the frame of the dispenser. So I just wanted to point out they're a traditional piping system versus what we call a loop system. Okay, so we're out at our plant here in Smithfield, North Carolina, and this is our rotomolder. This is where we make the polyethylene dispenser sumps, the polyethylene tank sumps that we talked about. So the way this works is there's a large metal mold that will hold the polyethylene pellets. So you'll see they'll open up the mold, they'll dump the pellets in the large metal mold, and you can see the machine holds several molds at one time. And what will happen is each individual mold will rotate, the whole machine will rotate, and it goes in the big oven. And what it does, it heats up the mold, and then the pellets will mold or will melt and attract and stick to the outside of each of the individual mold, and then it's then sent to the cooling chamber, and once it cools, you open the mold and the whole polyethylene sump pops out of the mold. And there you see a one-piece polyethylene dispenser sump being born.
Hi, I'm Chuck Liebal. I'm the product manager for the Fibrelite product line here, and I'm here to just introduce and talk a little bit about our manufacturing processes for making the Fibrelite sumps. So the method we use for manufacturing Fibrelite sumps is a process called RTM light. That's resin transfer molding, and it's considered the light style of production for this because it uses a vacuum assist to pull the resin. So as you can see, the associate right now is preparing one of our molds with fiberglass and laying the foundation of the fiberglass to the one side of this mold. RTM uses a closed mold method of fiberglass production. You can see this is the male end of the mold here, and there's an accompanying female end that looks like this on the other side. Once the layers of fiberglass are wrapped around the male end of this mold, the female side is put onto it and pulled down through a vacuum assist. The vacuum assist then pulls the resin through the mold system and into the actual fibers of the fiberglass on this mold. This takes about 30 minutes for the resin to fill up the entire fiberglass chamber, and at that time they cut off the injection of the resin, and then we allow for about an hour and a half for the cure time to occur on this. Now, the big advantage of having the RTM light process is you have a very consistent thickness and quality to the actual sump itself. And on both sides of the mold, you end up with a very smooth chamber wall on the inside and the outside.
Okay, so we've talked about pipe, and we've talked about the fittings that go on the end of the pipe, and we've also talked about containment sumps. Now, a containment sump is only going to work if it remains liquid tight. So the question is, how do we get a pipe inside of a sump and maintain that liquid tightness? Well, we do that by using what's called a bulkhead entry fitting, and those can come in many different shapes and sizes. For example, when many people use fiberglass pipe with the fiberglass sump, the pipe will actually be glued right to the face of the fiberglass sump with the fitting. In the case of the semi-rigid pipe or the fusible fusion weld pipe, they'll weld the pipe right to the sump itself with the entry fitting. But with the flexible pipe, there's actually two types of entry fittings. Now, obviously, we want our entry fitting on a traditional sump is going to come in the side of the sump, or on a tank sump, it's going to come in through the flat on the tank sump and allow the pipe to come in, penetrate, and then be connected inside. Okay, so with flex piping, we basically have two styles of entry fittings. The original style of entry fitting that's been used since the beginning with the flexible pipe is what's called a flexible entry fitting. Obviously, it goes along with the flexible pipe. It's made from a flexible rubber material. It's actually a PVC nitrile blend, and the way this works, it's a simple flange fitting. So the contractor will drill a hole in the side of the sump, then he'll drill out the bolt pattern based on the flange. This piece goes on the outside of the sump. This piece will go on the inside of the sump. The plate will go over the flange, and he'll tighten that down with a series of nuts. And the flange compressing will actually seal the entry fitting against the wall of the sump. Then as the pipe comes through, there'll be another clamp that tightens here and makes a tight seal around the entry fitting itself and the pipe as it enters the tank sump or the dispenser sump. Now, the newer method of bringing the flex pipe into the sump is actually with a rigid, what we call a rigid entry fitting. So it installs the similar principle of the flexible entry boot. Again, a single hole is drilled, then with a flange bolt pattern, the two pieces come together. There's a seal for the inside of the sump and a seal for the outside of the sump. The two pieces will come together, and then they'll be bolted down, squeezing the two seals together, creating a tight seal between the side of the dispenser sump or tank sump and then the entry fitting itself. Now, with a rigid, there's no, the boot's not flexible, so we can't actually clamp around the outside of the pipe. So what we do is we use a compression seal that will come inside. The pipe will transfer through here, and then as we tighten this nut down, it compresses that seal against the outside of the pipe, creating a liquid seal between the pipe itself and the entry fitting. Okay, so if you remember when we were talking about dispenser sumps, we described a traditional piping system. So on a traditional piping system, the way that the contractor determines where to install that entry boot, whether it's a flexible entry boot or a rigid entry boot, is as follows. So he knows based on whatever dispenser model that's going to be installed there, exactly where the product inlets underneath that dispenser are, and that's where our piping is going to come in. So by looking at the footprint of that dispenser, he'll know exactly where that product line should be, where it's going to line up with the inlet on the dispenser. So he may mark that on the side of the dispenser or on the frame of the dispenser, and then he's going to install what's called a stabilizer bar bracket. So actually the stabilizer bar is what's going to hold our impact valve in place. And if you remember, if you saw Gas Station 101, what the impact valve does is if the dispenser is knocked over, this top shears off and closes off the flow of product. So he'll install the bracket onto the impact valve. He'll put the stabilizer bar bracket, knowing exactly where this valve needs to be to line up. And then he's going to make what's called a riser assembly. So in this particular case, our riser is going to be a stainless steel flex connector. It's 1.5 inches. Now the other type of riser could be what's called just a rigid riser. It would be a piece of 1.5 inch pipe, usually a Schedule 40 pipe or maybe a galvanized pipe that will be cut to length and then threaded male and male on each side. Once he has the riser assembly threaded, or he uses a stainless steel flex connector, you'll put pipe dope on both sides, and then this would be placed in a pipe vise, and the riser will be threaded in the base of the impact valve. Again, that'll be in a pipe vise with the wrench tightened down, and then he's going to thread either a 90 or a T, or an elbow and a T on the bottom of the riser pipe. Again, this would be done in a pipe vise, pipe dope on the fitting, tightened down with the wrench. And now once his riser assembly is complete, he's going to put that assembly on the stabilizer bar bracket. He'll tighten that in all 4 positions. So now what this does, it gives him the distance from the top of the sump to where that 90 is going to match up with where the pipe penetration should come out. So once he knows that distance, he knows exactly where to drill that hole and place that entry fitting. Once the entry fittings are in place, then the pipe will come through the entry fitting, be connected, everything will be tightened down, and you'll have a liquid tight containment sump with your piping entering and connected to the riser pipe. Then once the concrete is poured, the dispenser sump will be set down, and then there'll be another pipe connection made from the top of the shear valve to the bottom of the dispenser, or the inlet pipe on the bottom of the dispenser, and you'll be ready to pump product through the pipe. Okay, so we showed you how in a traditional piping system, how the contractor determines where the entry fitting is going to be installed, how the entry fitting is installed, and then how he makes up a riser pipe and how everything is connected through the entry fitting into the riser pipe. Well, with the loop system, things are done a little bit differently. With a loop sump, the sump actually comes from the factory with the entry fittings, the stabilizer bar brackets, and the impact valves already mounted in place. And the way we do that is we know ahead of time, based on the site drawing, how the piping is going to be laid out. We know what model dispenser is going to be on that site, so we can build the sump in the factory specific to that site. We know the dispenser model, so we know where the product inlets are going to be. We know if there's going to be 1 piping, 2 piping, if they pass through, if they terminate, and we build the sump at the factory, so when it shows up on site, all the contractor has to do is actually set the dispenser sump, cut and couple his pipe, and then begin hooking everything up. So I'm going to show you how to hook up an REF here in a loop sump. So again, these would already be come to the site pre-installed. There's no need for a riser pipe or to make up a riser pipe assembly because my fitting is part of the base of the impact valve. So I simply bring the pipe in and make the connection to the bottom of the impact valve. So with the swedge on fittings, what we want to do is hand tighten that, and then I'll come back with the wrench and put about a half a turn on that. So once my pipe is hooked up to the impact valve, I center my impact valve, and then I can finish hooking up my REF. I'm going to push the seal down in there, make sure my pipe is centered, push down my compression ring or my compression nut, get that started, tighten that down, and I'm going to come back and tighten that nut all the way down to where it about bottoms out. So that's going to get tightened all the way down to where that seal is flush with there. So that's basically how the pipe in a loop sump comes through the sidewall of the sump, makes a liquid tight seal with the entry fitting, and then it's connected to the impact valve. Okay, so once all of our piping connections are made, this is what our sump will basically look like. Now, before we can flow any product through the system, the whole piping system needs to be tested. Okay, so the primary is easy to test because we can do it right through the impact valve, and then that primary actually is in connection with the other primary through the impact valve or through the Y fitting or the T fitting. So that's actually a continuous run. So if I have pressure on the primary pipe on this side, that pressure is also going to come across to the pipe on this side. But with our interstitial space, the way to test that in a continuous run, because our interstitial space stops at each coupling, we have to have a way of jumping the air pressure from one pipe to the other, and we do that with what's called a test jumper. So it's nice now with the new double wall couplings because I have that test fixture or that test port already built into the fitting. So once the jumper is hooked up across the fitting, and now gives a place for the air to travel across from one coupling to the other. So we test the primary pipe at 50 to 60 psi, and then on the secondary, again, because we've jumped across fitting to fitting, we can test the complete run or that complete product line with one test assembly. Again, it typically be a ball valve with a type of gauge, and then we put our compressed air on from a compressor, and then we're going to test the secondary at about 5 psi. So again, we would air up the primary, air up the secondary, shut those down, keep the gauges on, and then monitor that for any leaks in the system. Okay, so let's summarize the underground piping and containment installation process. So we'll take a look at this picture here, which shows a site under construction before it's been backfilled and concrete has been poured. So what will happen, the contractor, first thing he's going to do is he's going to set his underground storage tanks. Once those tanks are in place, he's going to mount his tank sumps. Again, remember those tank sumps can be either mounted on a riser collar or on a tank sump mounting flange. Once the tank sumps are in place, he can go ahead and install his dispenser sumps, and those will be set based on the drawing where each of the dispensers is going to be located on that site. That tells him where to put his dispenser sumps. Once all the sumps are set, he'll go in and install his entry fittings. Based on the submersible pump where the piping is going to come out, that tells him where to install that entry fitting in the tank sump. Again, that can be either a rigid fitting or a flexible rubber entry fitting. Go back to the tank sump. He knows based on that dispenser model where the product inlets are going to be, whether there's going to be 2 products or 3 products. He will make up his riser pipe assembly. That'll tell him exactly at what position to put the entry fittings. However, if it's a loop system, like the picture here, those fittings will already be installed for him, so he'll be ready to go. So once all the sumps are set, both the tank sumps and the dispenser sumps are set with entry fittings in place, stabilizer bars in place, he's ready to start running pipe. He'll take a measurement from his tank sump or from his submersible piping on a submersible pump, back to the first dispenser sump. He knows what that measurement is. He'll cut his pipe to length. He'll couple it. At that same time, he'll also cut his access pipe, the 4-inch chase pipe that gives him the retractability of that flexible pipe. He'll cut that to length. That piece of pipe will be installed in the tank sump, installed in the dispenser sump, and then he'll move on to his next run. He measures the distance from dispenser to dispenser, cuts and couples his pipe to length, cuts his 4-inch access pipe to length, puts those together, pops them in each of the dispenser sumps, makes his connection, makes sure everything tight, and then finish the rest of the piping runs. Once all the piping runs are in place, he'll go back, make sure all the fittings are tight, and then he will add his test jumpers that we showed, and the system will be ready to test. Usually it'll be at the last run, He'll put his test gauges on the primary pipe, 50 psi, put his test gauge on the secondary, 5 psi. He'll air up each individual run. So in this case, he would have 3 different tests, one for each product line. They'll leave the pressure on those lines during the rest of the backfilling in the concrete, just to make sure that the pipe hasn't been damaged during that process. Once the concrete's ready to go, they'll set the dispenser on the island and they're ready to pump gas. So that wraps up our Piping and Containment 101. I hope you enjoyed it. I hope you may have learned something. And again, take a look at our other series of videos by OPW, Retail Gas Station 101, Automatic Tank Gauging 101, our Dispensing Hardware 101, and then now our Underground Piping 101. And then after these, we'll continue on with a series of 201 videos where we'll get a little bit more in depth and talk about some specific regulations and some more specific products in each of those individual groups. I'm Ed Kammerer, and thanks for watching.